Hello, everybody. Welcome all to the session. It is the second session of drivers of lifestyle changes. And we're going to have like three presentations. Where the first one by Maria Teresa, the second by Ayami Otsuka, and the third by Grit Verbeek. So, without any further delay, Maria Teresa, the floor is all yours.
Thank you. Good afternoon, everyone. Thank you for joining this session, and thanks for to the organizer. My name is Maria Teresa Silvi, and I'm a pre-doctoral researcher at Universitat Autònoma in Barcelona. I'm presenting a chapter of my thesis on pro-environmental behavior. This is a work that I've done together with my thesis director, Emilio Padilla. The paper I'm presenting today is basically an econometric study, which focuses on the determinants of pro-environmental behavior. The motivation for this paper are relatively straightforward. It has been estimated that to maintain global warming within the 2 degrees, hopefully 1.5 degrees, the mitigation efforts must come from behavior change, and since it has been estimated that technological change won't be able to deliver the emission cuts that are needed. The literature on pro-environmental behavior is very vast. However, most of the literature focuses usually on just one behavior or one specific region, and very often it only focuses on one driver, either intrinsic motivation or social values or external conditions that could be economic incentives to behave environmentally, or green infrastructures that enable individuals to act pro-environmentally. And we felt that research that would collect all these factors together and try to assess the relative importance of these factors relatively to each other, and also we felt it was lacking, and we also felt that it was needed to conduct a study on a larger geographical scale to give to possibly inform European Union level policy. So the contribution of this paper, we mainly focus on the European Union. We include 27 European member states plus United Kingdom. We look at 8 pro-environmental behavior, which include recycling, waste reduction, water use reduction, energy use reduction, purchase of green products, purchase of local products, purchase choice of greener ways of travel, and reduction of car use. We also look into individual heterogeneity and its contribution to the likelihood that people will behave pro-environmentally, and particularly we have data on individual environmental orientation. We have data on their social demographics, and particularly on whether they have experienced economic problems in the recently. So our main research questions are: what are the main drivers of pro-environmental behavior? Are these 3 factors, social values, intrinsic motivation, and external condition, all important? Which is if there is one, which is the most important one? And are there differences among these behaviors that we're analyzing? And finally, we also ask ourselves, are there differences within the individuals that affect the effectiveness of certain policies? That is to say, does individual heterogeneity drive a different response to, for instance, external conditions to act environmentally? This is a simple outlook to summarize, a simple image to summarize our theoretical framework. So we assume we test whether social norms, intrinsic motivation, and external conditions affect pro-environmental behavior. We expect these three classes of factors to affect pro-environmental behavior directly, but we also expect that there are sort of indirect relationships between these components, and particularly we expect that social norms also indirectly affect individual intrinsic motivation, and we also expect that external conditions may have also an influence on intrinsic motivation. For instance, we expect that if a person lives in a country with very well-developed cycling lanes or recycling facilities, individuals may consequently be more motivated to act in a pro-environmental fashion. I will summarize the literature very briefly for lack of time, but basically most studies, as I said, focus on one of these variables, whereas studies that focus on all these factors are very limited. We found only 2 studies that focused on the impact of intrinsic motivation and economic incentives to act pro-environmentally, and particularly to reduce waste. However, the studies were focused on just one behavior, and we were interested in a wider set of behaviors, and we're mostly looking at regional differences, whereas we want to see what are the commonalities between member states, what are the policies that could work on an European, within a European-wide context. So our data come mostly from the Eurobarometer survey, which include 28,000 participants. And from this database, we have data on self-reported pro-environmental behavior, socio-demographic data. We have data on environmental attitudes and environmental orientations, on individual economic problems. Then we also have data from the Container Recycling Institute, which lists all countries which have container deposit scheme in place. That is to say, all countries that have these machines that you find outside the supermarket that collect empty bottles or cans and give you money in exchange for this. Then we integrate, we take prevailing social norms from the Hofstede Cultural Dimension database. It's a database that summarizes cultural values in countries, and with using indexes from 0 to 100. And later in a second, I will show exactly what kind of indicator we're using. First, I would like to show first look at qualitative data. As you can see, the average number of pro-environmental behavior that European countries adopt varies quite a bit. We go from the 4.3 average behavior per individual in Luxembourg to the 2 behaviors in Bulgaria. And we color-coded the countries so that you could sort of probably see a sort of a regional pattern emerging, with Eastern Europe countries and Southern countries being grouped mostly on the right hand of the graph. And so this suggests that the countries which are regionally proximal have similar patterns when it comes to pro-environmental behavior. And we wanted to investigate why is that. Is because there are communal social values or history. In this second graph, we see instead the percentage of individuals who ascribe to personal responsibility to protect the environment. The darker the bars, the more people are committed to protect the environment, personally committed to protect the environment. And here again, we see a huge variation between the Netherlands, who have 72% of individuals who commit strongly to protect the environment, and to 22% in Poland of people who say that they have a role in protecting the environment. The third graph sort of pulls the previous two in one. And so on the vertical axis, we have the average number of behaviors adopted by country. And on the horizontal axis, we have the percentage of people in each country that reject any kind of responsibility to protect the environment. And we can see that there's an inverse relationship. So the more defectors, the more people rejecting for responsibility to care for the environment, the fewer pro-environmental behaviors this population are likely to adopt. And again, I would like you to notice here that there's some kind of a regional pattern where also in this graphic you can see that Eastern Europe and Southern Europe are sort of like more grouped towards the bottom right hand of the screen. So the econometric model looks at focuses on each of the 8 behaviors separately, and the indicator that we include for each behavior are these. So for prevailing cultural norms, we include 5 dimensions of the Hofstede cultural database. We include an index for individualism, one for long-term orientation, one for power distance, one for masculinity, and one for indulgence. And these are just indexes from 0 to 100 that measure how one country scores relatively to the others. Then for intrinsic motivation, we include 3 indicators that measure whether the person recognizes the environmental norm connected to the behavior, whether the person ascribes to personal responsibility towards the environment, and whether the person is worried about the environmental consequences of her own act connected to that specific behavior. That is to say, if we're looking at water use reduction, we look at whether the person recognizes that as a norm, the fact that you have to save water, and whether the person is concerned about water scarcity. In external conditions, we include whether the country has a container deposit scheme in place, therefore they reward economically people for recycling, whether the person has financial problems, and I will explain why in a minute. And we include an individual assessment on how well the state is doing in protecting the environment. And we take that as a measure of the goodness of the green infrastructures in the country. So probably you have to zoom in a little bit. I'll try to do it for you. So our results mostly show that between these 3 classes of factors, by far the most important one is intrinsic motivation, and specifically recognition of the norm, followed by ascription of a personal responsibility and environmental worry. And this holds for across all behavior. This table basically summarizes what you can see in the previous table. It just reports the sign of the coefficient for whenever the coefficient is statistically significant. The indicator for the coefficient for the container deposit scheme is positive. It means that recycling is positively affected by the presence of this container deposit scheme. However, its impact is rather limited. When it comes to green infrastructure, we got mixed results. Some behaviors seem to be positively impacted by the availability of the goodness of the infrastructures, whereas we didn't find any effect for others. Social values have an impact on different pro-environmental behaviors, although some are more affected than others. Particularly, waste reduction and recycling are particularly affected, whereas other behaviors such as water use reduction and energy use reductions were relatively unaffected. We wanted to see whether different people react differently to the same programs and variables. And therefore, we cluster individuals into 3 groups based on their level of ascription of personal responsibility. People who ascribe to a high level of responsibility were clustered in the high responsibility group, and people who decline any responsibility to protect the environment were clustered in the no responsibility group. And then there's the middle group, middle responsibility. The main, and we ran basically the same analysis to see whether the value of the coefficient changes across groups. And the main finding was that actually people who don't ascribe to any responsibility to care for the environment are unaffected by their own worry about the environment. Even if they're worried about environmental consequences, this doesn't move them to act. The availability of green infrastructures that could help them to behave pro-environmentally is ineffective, and also financial problems don't affect their likelihood of behaving pro-environmentally. And here I actually forgot to mention one thing. Financial problems, whether if an individual is experiencing financial problems, there is an effect on all behaviors observed. The effect is negative for all behaviors that imply a cost, such as buying green label products. And this is sort of understandable because often green label products are more expensive, but the effect is negative also for those behaviors that are cost neutral, such as recycling, which was somewhat surprising. Individuals with financial problems are more likely to reduce water use. And this was expected because, of course, if you reduce water use, you will have a lower water bill. But this was not reflected in energy use reduction. So basically, even if a person has economic problems, he or she is not more likely to reduce her energy use. And we felt that this difference between the effect on energy and water use is probably connected to the pricing schemes available in Europe, where water use is linked to a volumetric tariff where you pay based on how much you consume, and then electricity contracts instead are nowadays more based on time zones, and therefore people are pushed to optimize, to lower their bills by simply shifting when they consume energy, but not necessarily to decrease energy. So this was for us an interesting finding. So to quickly summarize our findings, we conclude that policy should pursue 2 different layers. On the long term, policies should be focused on increasing intrinsic motivation for the ones who are not intrinsically motivated, because if individuals don't ascribe to a minimum level of personal responsibility, they won't be receptive of, for instance, very good infrastructures or economic incentives to behave pro-environmentally. But on the other hand, external conditions, so improving green infrastructures, can help, on the other hand, increase adoption rates of pro-environmental behavior among people who are committed towards the environment beyond a minimum point. We also observe that there are demographic variables which affect pro-environmental behavior. For instance, that being a woman is systematically associated to a much bigger likelihood of behaving pro-environmentally for all the behaviors we observed. And this implies that policies should also be sort of gender aware and target perhaps men a bit more. And there are also the paper, which is available by demand, has a table with some summarizing conclusion for what are the recommendations to improve adoption rates of each single behavior. I hope I haven't run out of used too much time. Thanks for your attention, and I'm available for questions.
Thank you very much, Maria Teresa. That was great, and that was very accurate in terms of time. So we have left some couple of minutes for some questions. Fiona, first of all, asks about one of the Hofstede's cultural dimension. What is power distance?
Okay, power distance measure on an index from 0 to 100 whether how hierarchical a society is. So the flatter the society is, it's the lower the value, and the higher, the more distance and structured the society is.
Great. And then Ivan asks some econometric questions. One quick one, whether it was the dependent variable categorical or continuous. And then he's wondering whether you used fixed effects on her.
Yeah. Okay, so thanks for the question. All the dependent variables are dummy. Zero if the person hasn't adopted the behavior, 1 if the person has adopted the behavior. Therefore, I use logic regressions, and I use country fixed effects.
Great. And one more question by Ivan. She continues, and do you consider to test formally for complementarity between internal motivation and external conditions? I guess she's asking whether they can be seen as complementary, or
there is a lot of research on whether one crowds out the other. So whether, like, for instance, providing economic incentives crowd out internal motivation and has the actual effect of lowering pro-environmental behavior. In this case, I have tested whether providing economic incentives, such as to recycle, for instance, influence recycling behavior, and the answer was that the coefficient was statistically significant and positive, although not very big. I don't know if this was the question.
Yeah, I think you answered the question. Great. Well, I think that's alternative education approach for buildings. The floor is yours, Grit. Thank you very much.
Thank you. I hope everyone can hear me well. Okay, I will present results from the PhD, from the doctoral research by Anne Bosseret. She's one of my PhD students. She's also in the, she already presented herself. And it's on energy sufficiency as an alternative renovation approach for buildings. And what she did was a research by design exploration of 3 large underused houses in Flanders. And we're part of the Faculty of Architecture, and that also explains our focus. So if we talk about energy sufficiency, I think if we first have to talk about energy efficiency, because energy efficiency is in many energy policy actions a very important focus. Also in Europe, it's considered a key measure against climate change. But if we look more closely to energy efficiency, what it means, then we can say that it considers a provided energy service per unit of energy input. And if we talk, for instance, about heating a building, then in an energy efficient building, heating requires less energy input. So we get the same service, but for less energy. So the focus of energy efficiency is mainly on the energy input, and energy efficiency doesn't question the energy service. And this leads to some drawbacks of energy efficiency that has a negative impact on effective energy savings. One is the fact that energy efficiency is expressed in a relative scale. And so it doesn't look at the absolute energy consumption, but at relative energy consumption. And in a building, it's kilowatt hours per square meter floor area. And so it neglects the impact of the building size. In energy efficiency of buildings, we also considered standardized norms for thermal comfort, and this means that typically acclimatization systems, heating systems are designed to provide thermal comfort in rooms and buildings as a whole, regardless if these rooms are effectively used by people or not. And it makes also abstraction of the social context, means that it doesn't consider or take into account the residents' actual and dynamic everyday behavior. There is quite some critique on this very strong focus on energy efficiency. And so there is a growing call to implement more energy sufficiency. It's not meant to replace, but as a supplement to energy efficiency. And so with energy sufficiency, the focus is much more on the energy service. And we try to rethink the quantity or the quality of an energy service. We want to provide enough of this service, but avoid that too much is provided. And an important network on energy sufficiency is the Enough network, and they call it living comfortably within the limits. And for those who are not so familiar with sufficiency, I added here some interesting links for those who want to know more. In literature on energy sufficiency, you typically find three types of interventions. One is reduction, so a quantitative reduction in the need or in the demand of energy, for instance, lowering your indoor temperature, or providing less space, designing a house with a smaller living area. Another type of energy sufficiency intervention is adjustment of the quantity or quality of the energy service, so that the energy service is adjusted to the actual need. This can be, for instance, adjust your space and make flexible spaces so that you can adjust them on that dwelling level or on room level to the actual need in the space, or a smart radiator valve that adjusts the heating to the occupation of the space. And a third type of energy sufficiency intervention is substitution of the quantity or quality of the energy service. And this means that you try to provide or transform the basic needs differently. And a typical example is drying clothes. When you just look at energy efficiency of clothes dryers, you never come up with the idea that you might just use a washing line. A washing line is a different transformation of the need to dry your clothes. And if we talk about buildings, sharing spaces could be a way of differently providing the need for space by providing more communal and less private spaces. So what is in fact the problem? If we look at the current energy policy, there is a very strong focus on energy efficiency standards. New houses all over Europe have to meet energy efficiency standards. There are energy labels used for existing houses to express the energy performance, but this is as an efficiency, not as a sufficiency. So it gives you the consumption per square meter, but doesn't give you an idea of the overall consumption. And what we also see is that policy campaigns try to convince homeowners to renovate their houses in an energy efficient way. But if we then look at reality, and I don't know, maybe Flanders is untypical for that, but we have quite a large number of old, large underused dwellings that are occupied by mainly baby boomers. And of course, because of the fact that it's already a large house and underused, residents already tend to adopt an energy sufficient attitude, because otherwise their energy bill would be too high. So they just heat only some rooms, and they even sometimes migrate within the house along the seasons and live in a different place in winter than they do in summer. or they try to make in one way or another large rooms smaller. And in these houses, these residents tend to consume less energy than you would expect if you calculate it according to energy efficiency standards, which sometimes is called the pre-bound effect. On the other side, if we try to convince these homeowners to renovate their house in a typically energy efficient way, there is a risk that these residents will be nudged to climatize the whole house because they expect to have a lower energy bill. And so that is what is called the rebound effect. On the other side, it's not just about energy, but especially because it's our large houses, there is also the fact that if you want to renovate them in an energy efficient way, it will cost you a lot of money, and also a lot of materials have to be used. So the starting point for the research question for this research was, is there no alternative renovation approach to reduce the actual energy consumption? And so what we did was a case study of 3 large underused houses. And in fact, it was not difficult to find participants for this study, because once we started to talk with people living in this kind of houses, they were eager to participate because it was actually something they were struggling with. And so what we did was an in-depth study of their dynamic behavior and the comfort experience throughout the seasons in a kind of ethnographic study. So with semi-structured interview, guided tours, photographic journals. The residents' behavior and experience was coded and visualized. We mapped their actions and their interactions, and also tried to see what were already energy sufficiency interventions undertaken by them. But in the end, as we are part of the Faculty of Architecture, we were mainly interested, how can an architect design for energy sufficiency? And how can we support designers towards this designing for energy sufficiency? So from this study of the behavior and their comfort experiences, we found we deduced 4 groups of factors that express the residents' interaction with dwelling in an energy-related context. We have behavior-related factors on their actions, on their occupancy. We have comfort-related factors on type of comfort, on level of comfort, and on their priorities and preferences for comfort. We have environment-related factors, both for the building spaces and the natural environment. And since we specifically also wanted to take into account their dynamic behavior, there was also this time-related factors between winter, summer, along the day, along the week, and so on. Just some examples of relations between these factors is in your is what I already told, the summer-winter migration. So in 2 of the 3 cases, we found that residents migrated to a different place in winter than in summer as their main living space, and what you see in the left top. And this was strongly related to what you see in the bottom right, with fact that the climatic conditions were changing around the house, and also in the house shaped the thermal comfort over the seasons. And so this comfort that they experienced that motivated their behavior. Another example is on the top right, where in fact you see how the residents' living environment shapes their comfort, and this is comfort experience visualized in an office space at home, sitting in front of a radiator and of a window. And then in the left bottom, you can also see how the use of indoor spaces changes along the seasons, and this because of their comfort experience, and this of course has an impact on their energy demands. So we came up with a kind of relation within, on one side, an active resident who performs energy-related behavior to manage his or her comfort experiences and needs. And both the actions and comfort experience were strongly influenced by the dwelling, the living environment, built, spatial, and natural environment. And these 3 together, this interaction, has an impact on the energy demand. And of course, as we wanted to see this along the seasons, there is also a time framework on top of it where this changed over the time, over the seasons. So how was the research by design then done? So based on these findings, a design process was undertaken for each of the cases with 3 phases: an analysis phase, a synthesis phase, and evaluation phase. And this way, case-specific findings were developed and then they were brought together. And for this research by design process, there were 3 design goals that were important. So the first design goal was that we wanted to integrate the residents' dynamic way of living throughout the seasons. We wanted to centralize residents in each phase of the design process by means of placemaking, and I will come back to that later on. And we wanted to increase energy sufficiency of the spaces and also stimulate a more energy sufficient way of living by means of these 3 energy sufficient interventions that I mentioned earlier: reduction, adjustment, and substitution. And so with these results, we came up with, we tried to develop methods and guidelines to support designers who want to design for energy sufficiency. So what we found from this study was that a very important element, especially if you want to design for efficient energy sufficiency, is designing for placemaking. Instead of designing a building as a whole and rooms, etc., places were a very important concept, and it's a concept that is known before but never was a link made with energy. And places only exist through the eye and the experience of the residents. And in fact, for a resident, a house or dwelling is a collection of places and non-places. And so in this research by design process, the first step was the analysis step to identify places and to identify also opportunities for energy sufficiency through an analysis of the behavior, of the comfort experience and the interaction, and on the other hand, to an analysis of the spaces. And then in the synthesis, there are different steps in the design process. So in the conceptual design phase, these places were grouped according, you have places for to cook, to rest, to work, and then according to the different factors, they were grouped. And in the right, you see some examples of how this can be grouped. And then in the next step, in the preliminary design, these places were zoned. And there are different ways of zoning. On the left, you see linear zoning between warm and cool places, or between winter and summer places. Or another example is what we saw that many places, like warm places, were decentralized, and so that was tried to zoning places by centralizing, to go from decentralized to centralizing places. And also in this phase, spaces were linked and looked at how spaces are linked to each other. And there in the left, you see different ways of how places can be linked, interlocking, or a space can be a space within a space, can be an adjacent space, or can be a buffer space between, as a common space between others. And the nature of the link can also be different, and that's what you see in the right. A link can be closed link, an open link, or flexible link. And so by putting all this together, in the end, in the detailed design phase, dynamic spaces were created where all these elements were combined. As a conclusion, we could say that if we oppose energy efficiency and energy sufficiency, you could say that energy efficiency in a building is in fact creating a project. What you try to do is to create an energy efficient house, while when you try to design for energy sufficiency, it's about a process and designing for a practice. You want to design in a way that a resident is able to dwell energy sufficiently in his house. And so dwelling sometimes is used as a synonym for house, but here's the act of dwelling. And this also asks for a different design approach, sorry, where for energy efficiency, there is a very strong object-oriented approach where architects try to apply a list of energy efficiency measures in order to end up with an energy efficient design. Whereas what we saw is that to achieve an energy sufficient design, it's very important to have a resident-oriented approach, and a very important approach in this appeared for us the approach of place making, so identify existing places and creating new ones. And this was really an important starting point for design that is oriented to the resident. And so, and how then to come to energy sufficient design is by making these places comfortable instead of making rooms or buildings comfortable. And so this was also, we did some tests, several years tests with students to test the tools that we were developing. And what we really saw is that students are, well, architects are very strongly trained in object-oriented, object-centered design, design the building as a whole. And for energy efficiency, they try to optimize the building skill, they try to optimize the building systems, but this also creates a constant environment, a controlled environment, and also a very static environment. And we noticed that there is a very strong need for design supportive instrument to make architects switch to a resident-oriented design. And so this placemaking is a starting point, because you can only talk about places by relating to the resident. And it enabled also much more dynamic way, a design that enables a dynamic way of living throughout the seasons. And so several design tools were developed to get to know places, and this was then combined with insights that we have from climate responsive design, building with adaptive ability, and user-centered design. So this is in brief an overview of the research that we did.
Thank you very much, Ruth. Thank you for the nice presentation. And we have some time for questions. Anne is already responding, but yeah. Let's take Claire's questions. She asked, how extensive was the reconfiguration in the design, changing internal partitions, external openings?
Yeah, I think well, it's a part of the solutions. That is changing internal partitions, but very often in a flexible way. So making it possible that internal partitions are flexible, so that they can be adjusted so that you can adjust spaces into spaces that are sufficiently large enough depending on what your need is. That was certainly one of the elements to achieve an energy sufficient design. Yeah.
Okay, great, thank you. And one more question by Francisca, that she's asking whether after the experience of COVID, now people that they will be less prone to adopt this kind of solutions that reduce floor space.
Yeah, well, it's an interesting one, because I know I've been thinking about that also already during this situation, because now that also in Belgium there is a strong promotion of making houses smaller and letting people move to apartments in cities and so on, and of course in this situation those people who live in a large house on the countryside are very happy. But I think what we focus and I do think that COVID has to make us aware of the risks of just people putting people in very small places. But here we really had the focus on this large underused houses where there are many in Flanders, and where we see that, well, people do not renovate for energy efficiency because, well, most of the time it's much too expensive, and also the amount of materials. And so it was specifically for these large houses that we thought, are there other ways of dealing with these houses? And then I think this is not really in conflict with situations like this COVID-19, so that you still can use a space that you need at a certain moment. So I think designing in an energy sufficient way can, even for a COVID-19 situation, maybe even be an advantage, because you are able, or should be able, to adapt the space on the depending on what you need. And so if it's just reducing your floor area and say, okay, everyone should live in a very small house, then there might be indeed problems. So yeah,
exactly, it might even have like a positive effect. Who knows? So, Grit, I would like to thank you very much, and I would like to thank all the participants of the speakers of today and the attendees. And just to let you know that we have the virtual bar. You can join. More information you can find on the Discord on the general tab.
okay.
Well, thank you very much, and once again, thank you very much, everybody. Have a nice one. Bye-bye.
Bye.
Bye.